Hello everyone, I am Makohin. I am Product Manager Asset Integration here at gridX, and I'm here today to speak a little bit about navigating the path to interoperability and, so to say, about the integrations that we made here inside of gridX. You may be asking yourselves, what is integration? Well, basically, in integration we deal with different distributed energy resources. This is a multiverse of assets actually. You can see right there, we have many different things. PV panels, batteries, EV chargers, meters, and all of them speak a different language. No matter if the OEMs use the same protocol or some similar languages, well, in the end, they are still different. And this is a big challenge for us because after all, we have to present this all in a singular way towards everyone. So how to do this? How to make it possible? Well, this is easy, it may like easy, but this is an integration process. And what is an integration actually? From a first glimpse, it may look actually simple. A simple, straightforward process with learning, developing, and deploy. So you might think we can just learn documentation, see how the appliances communicate and talk to themselves. After we learn, we develop a scanner, a driver that speaks to the appliance, and later we deploy into the field. Easy peasy, right? Well, in fact, the process is not as straightforward as it looks. Unfortunately, we have many different problems, and I have brought some of these problems to show you. First of all, sudden firmware changes. If we go to the field with looking at the appliances, sometimes the OEMs change what is inside of the appliance because they need to have safety concerns, we have improvements in the products, so they need to update it. But sometimes this updates messes with the communication, and therefore it's not easy for us to continue communicating with this asset. Well, next we may have some inconsistent assets behavior. What is this? Well, basically not everything has the same behavior all the time. We have corner cases, we have different conditions in the field that lead towards different behaviors. And because of this, we are sometimes hitting a very shady area of the behavior that we couldn't account for before. And we need to handle this after they happen. Also, low OEM support. Well, OEMs may not have this strategy of offering a very good interface for the external parties because they may have, I don't know, sometimes a very vertical strategy of providing the whole solution from the appliance to the HEMS. So we have to deal with this as well. Even though they offer an interface, they will not be so quick in giving us support. Going further, we have poor asset documentation. Well, again, sometimes because of focus, sometimes because of other reasons that we cannot account for, documentation for the asset is not perfect. Then we have to interpret it, we need to get more information from other sources and locations, and this is not an easy task. And latest, legacy and custom interfaces. What is this? Well, because of many different reasons, the OEMs may want to stick to some old interfaces because it might be cheaper for them to develop because this is in their domain, right? Therefore, we have to use these old interfaces that we cannot find that much information for in the internet or even if the OEMs themselves sometimes. So how to overcome of this process? This is the challenge of integration, right? And what we at gridX do, we basically provide all of this multiverse of assets, of OEMs, of different appliances in a sort of a singular one source of information to you in the platforms. Basically using Xenon and Phoenix as the front-end platforms from our company, but also sometimes to APIs when needed, right? This is one of the most important values that we can bring. But the path for integration is not easy. Navigating these waters is just like the old sailors in the great navigation times when had to go through the Cape of Storms at that time to get to the east. And then right now we have the Cape of Good Hope because they found a way through it. And we are finding our way through it as well. You can see here 9 steps from an integration request to the maintenance phase where the appliance is really used in the field for the best of purposes. And what is actually this path? I'm going to show it to you right now.
Yeah.
All of it starts when there is a need for an integration. There is a need for an asset that's really important for market reasons, for strategic reasons. So our partners come to us and say, hey, I need this integration done because I want to roll out that into the field. Then we think, okay, let's see how that plays out within our strategy. So after the request, what we do, we prioritize. The prioritization is basically when we assess the integration, this asset, the specific asset, and see, okay, what is the potential impact for it, for us, for our customers, because we are also helping our customers to get the best of what they have at their disposal. What is the timeline planned for this integration, right? Of course, resources are limited, so we have to think and plan according to timelines. Then the physical feasibility of the technical parts. Is this really feasible for us? Is the interface correct? Is everything suitable to our needs? And then the strategic alignment. You may think, okay, you can integrate everything then. Yes, technically you could, but we won't do it because it may not be part of our strategy. If someone comes for us to integrate maybe a smart refrigerator or a smart air conditioning, it might be not in part of our strategy, so we may not do it. It's part of prioritization. This is very important. After we prioritize that, we see that we're gonna do it because it makes sense, it makes part of our strategy. What we do, we start an evaluation. This is a step where we go deep into the information we have in our hands. We study documentation, installation guides, commissioning guides, memory maps. We see if the appliance really has everything we need to provide the best value, the optimized value for our customers. And how we do that? Basically, we see, do we have all the documentation? Is the OEM actually supportive toward us? Because if we have doubts, we would need to go to the OEMs and we expect to get answers from them. We also look if the documentation is actually complete with all the information and if the assets interface comply to what we have in what we call our gridX interface requirements. It's a document, a set of requirements that says what are all the necessary things an appliance needs to have, an asset needs to have to be compliant to us. And also we evaluate if we have a plan for testing. After all, if we want to get the best of the assets, we need to get our hands on it so we can test it on our own, so we can see its real capabilities. It's hard to test something we have no direct contact to. But okay, we evaluated it. We saw that it's actually possible to integrate, so what we do next? We start an exploration round. An exploration round is something that is even deeper than the evaluation because we actually get our hands in the device. We get our development team, we get the documentation, and we start to manually test this asset to see if are all the necessary data points available for us. We see if what is in the documentation actually fits the real world. Then we can also say if we can truly control the asset. Okay, documentation says we can, but can we really? And then we see if there are any specific requirements that we need to fulfill. For example, an inverter. If the inverter suddenly loses the communication towards the grid box, we need to know what's going to happen. And this thing that's going to happen needs to be foreseeable. And this is what we call fallback behavior. This is really important for us for controlling assets in the field. And finally, we see if the interface is valid according to a standard that is based upon. Yes, we did the exploration. We found out how the integration works for that asset. What we do next? What we do next is start a benchmark. And what is this? Basically, a benchmark is looking at the asset and looking at its response time. Is it quick enough for us? Is it stable enough for us? Can it be tracked? And we also compare these assets towards other assets that we have already integrated before to see how it goes well against the other competitors. This is important for us to know the whole landscape and also to see if we have to adapt our algorithms somehow towards this asset. Yes, we went through the request, prioritization, evaluation, exploration, benchmark, and now what we do? Well, now it's where the fun really begins for the development team. We do the implementation phase. Here is where the code is written. Basically, we write code for two pieces of software, which is the scanner and the driver. The scanner is the software that goes through the network, look over for some assets that may say, hello, I'm an asset, look at me. and identify these assets, and then add a virtual entity for this asset inside of our systems. And what is this virtual entity? Well, this is the driver. The driver is basically a blueprint for the communication. It's the translator, the ultimate translator for the assets, the DeepL, the Google Translator on the field. And this contains all the necessary transformations, filters that make the data come from the field and go to the cloud in a single way, but also get all the commands, translate it, and leave them into the field so the asset actually understands our commands. And then, when they have the implementation done, we go to testing. This is where we get this driver, this just recently developed driver and this scanner we put into the field to see if it really works in practice. But we do that in our lab or in any kind of very controlled location where we can stress as much as we can, but in a controlled environment where we're not going to bring any prejudice to anyone. So here in this part, we do a characterization test to see the profile of the behavior of this appliance with our EMS, with other software components that we have, and we even look at the capabilities of this asset to fulfill other use cases, other advanced use cases that we have, like time of use optimization. We look if everything required is actually available to us and if it works really well. Okay, we tested it. It works well. What we do next? We roll out. We get this driver and this scanner and we launch it into the field, but in an alpha stage. So we still consider that a test stage that we do in the field where everything can happen with a limited amount of locations. And this is where we really see how the asset will behave with the end user. In the alpha stage, SLA terms do not apply because it's still under testing. And at this phase, the asset integration can actually evolve towards other steps to beta and then stable. Beta is still considered test phase, so still SLA terms do not apply, but we can already spread it towards other locations. When we have the integration stable, it's working well in many different locations according to what we consider a very gold standard with our use cases, then we move this integration to stable. And when we do that, well, the integration enters what we call the maintenance phase. Here is basically fixing bugs, looking for firm updates from the OEMs, checking if everything is working according to what we expected, and if something doesn't, we fix it. Or we can also improve it. We have a new use case, we have a new algorithm, we need new things from the asset. What we do? We adapt. So this is what we can do, and we do it very greatly. But at some point, well, every party has its ends, so some appliances integration may find its end of life. When does this happen? Well, there are many cases, but one remarkable one is if the OEM stops producing this asset, if they abandon this asset, well, then we also sunset our integration, because if the OEM cannot provide us support, if something happens in the field, we cannot help our customers as well. This is a very important process and is part of any product that we have in the market. Well, so we have these 9 steps for integration, and how does this really works in practice? This is not everything. For this path to be feasible for us to be able to navigate in this path, we need some very important pillars, and I have 4 important pillars to bring here, which is all based on cooperation, collaboration with us, our OEMs, and our partners. The first pillar, fast support channel. When something happens with an asset in the field, what we need their help to solve it, right? And sometimes the other way around, so we have to have a quick communication. This is the first pillar. We and the OEMs need to collaborate a lot and close. Second pillar, clear documentation to enable quick fixes. Sometimes if the documentation is clear enough, we don't even need to go to the OEM. We have all information in our hands. If the documentation is clear, this is possible and everything is quick. Third pillar is the joint firmware management between us and the OEM. And what we do in here is basically getting grasp of the pre-release firmwares from the OEMs and test it before they hit the field, so we avoid any surprises when this happens. This is already happening with some OEMs, and gridX already And these are one of the best integrations we have in hand because we test everything. And the fourth pillar, joint testing between gridX and the OEM. This is also happening with some of the best OEMs we are integrated with, and this means that they sometimes have a grid box in their lab, we have their assets in our lab, and we both test from both ends. This ensures quality, this ensures that everything works for the best for everyone. After all, both asset and the gridX platform have to work really well for an integration to be successful. So these pillars enable us to navigate through all this path of integration, and all of this thing together is what makes it possible for us to consider that, well, the Gridbox is a polyglot. We speak many different languages, so to say. We integrate over 50 different OEMs, and if we go to the models we integrate within each OEM, is over 75, 80 integrations that we are actually compatible to. It's a whole lot of different appliances that we are compatible to. And this is great, this is not easy, this is really hard to maintain, but we make it because this is what we do. We adapt, we provide good solutions to everyone.